Welcome to Homework Lib.
So this question is asking us about basically there's a few parts in this question. The first part is asking us to sum the proposed mechanism to create a balanced equation. So for part A, our given equations that we have to add to figure out the final balanced equation is first this, and then the second one is this. So what we're going to do is pretty easy here. We're basically going to sum these equations. When we sum them, we're going to cancel out things that are the same on both sides and then just add the rest through. So your final equation would be 2NO plus H2 on the left side goes to NO2 plus H2O. And let's make sure that our equation is balanced. So we have two H's here, two H's here, two N's here, one N here, two O's here and three O's here. So basically what we're going to need to do is we want both sides to have two O's. So we're going to multiply through, let's see. So I guess we actually want both sides to have, let's see. So sorry about that. I'm actually messed up. This is not NO2, this is N2O. And this is also not NO2, this is N2O. So now if we look at it, we're definitely balanced because we have two H's, two H's, two N's, two N's, two O's, and two O's. So this is going to be our final equation, final balanced equation. B says write a rate law for each elementary mechanism. So each elementary mechanism is actually going to be the step. So this step, rate law, is just going to be rate equals K times the reactance. So K times NO2 squared. And then for this one, it's going to be rate equals, again, K times the reactance. So O2 times H2. And I apologize for that being a little bit difficult to see. Part C says identify any intermediates in the reaction. So if we go back to our first page, intermediates in a reaction are something that is both produced and reused. So something that's produced in the first step is N2O2. Now, if it's reused in the second reaction, it's going to be considered an intermediate. And we see that N2O2 is truly reused in the second reaction. So we're going to say for intermediates, we have N2O2. Part D says the observed rate law is rate NO squared times H2. If the proposed mechanism is correct, what can you say about the relative speeds of the first and second reactions? So let's go back to that first page. So they're saying the rate law is NO squared times H2. And what does this tell you about the relative speeds of the first and second reactions? Well, what this tells you is that the rate determining step is going to be the slow step. So whatever is in the rate law as the rate determining step is going to be the slow step. But since we have NO squared from the first reaction as well as H2 from the second reaction in our final rate law, that means that we have steps that are equal speed instead of one being fast and one being slow. If only NO was in the rate law, that would be the slow step. If only H2 was in the rate law, that would be the slow step.